So this is how I did this question. Now, there's something wrong with this question. Actually, none of the below options are correct because this question is asking about the commutative law or property. Generally speaking, AB is not equal to BA. Generally, not commutative matrices. When you multiply them, you don't get the same answer. But under certain conditions, you do get the same answer. So I try taking each and every one of these matrices and I multiply with this one. I started with this one here. There it is. And then I multiply with this one. The reason why I have a 0 here is because they said here A and D are the same. And then they also say that so A and D are the same, so I made it to be A. This is what I get. And then I did it the same thing here, but swap them around. B this side, A the other side. This is what I get. As you can see, these answers are not the same. These answers, they're not the same. I did the same thing with the second matrix. In this case, I put it B2, and then the third matrix B3. I still don't get the same answer, which proves that generally speaking, these are not commutative. So none of these forms can commute with this matrix. I guess he meant to put another option here, but this question is wrong because none of the below options are true. So let's move on to the next question. This question is 27. Question is it? Yeah, it's this one. Let D and let me just pause a bit. I'm just gonna copy one of these pages and I'm gonna paste it here. I didn't delete this. I did this first. Cut. Add. And paste this. To go back again and where is it? It's this one. Paste. So you had to choose this question says let D and E be non-singular matrices. Prove that DE is invertible. So basically you have a situation here where D and E are invertible. And just a little bit of info. If they say something is invertible, it means that prove that the matrix DE is invertible. It means that I can, for example, D is invertible. It means D, if I multiply D with the inverse, I'm gonna get I. It means it has an inverse because it's invertible, right? Even also E, because E is invertible, it means I can find an inverse of E. Inverse of E, and I'm gonna get I, right? And like I told you, matrices generally are not commutative, but if you are multiplying inverses are commutative, because if I take this and I multiply it by this, I still get an I. So they are commutative. E times should get an I. identity matrix. So this is information you need to know about it. When they say something is invertible, this, you should know this. And now if you know this, then this question proof. Say proof. Proof. This question becomes easier now because they want us to prove that DE is it's an invertible, right? It's non-singular in other words. How do you prove that? Well, we have DE. If this is invertible, when I multiply it on both sides by D minus I, I'm gonna multiply it on both sides. D, sorry, DE minus I. See, this side is on the right, this side is on the left. So if this thing is invertible, I must get an I. Do I get an I? Let's see if I do get an I. Let's see. DE, and then this will be E D. Is this property when you have A B, this becomes B A, like this. So you swap this two. So we did swap them, and then I just associate this like this, just changing the brackets. I haven't moved anything around. You can't just move matrices around as you like. This will give me I, right? And then this will give me DD. It's the property, this property, AI equals to A. Then this is I. So far, so good. Let's check this side. Do we still get the same thing? I get E, I, D, then E. Then I can associate these two. And I get an E, which just happened. I'm gonna get an E, then I'm gonna get an I here. I'm gonna get an E. Then this is E, which is I. So both conditions are met. This means we have proven that this is it's invertible. Therefore, DE is invertible. We could do this. We could do this because we've been told that D is invertible, so it does have an inverse. E is invertible, so it doesn't have an inverse, and that inverse we said it was E to the power minus I. So you have to look for an option that is like this among the options here. But yeah, basically look at this question again, and then you look for an option that is showing something like this, exactly like this. Let's move on to the last question, which one was it? I think it's this one. Yeah, it's this one. Let's copy it. We will copy it or delete of this. Let's go back again. What's this one? Which one is it? This one could be. And paste. Let's see. Yeah, these are the options of the yeah. So let's figure this one out. We need to, they've given us this, and then we need to find B, right? So we have C, B, T is equal to, just gonna multiply by the 3 here. 6, 9, 3, 0, minus 3, right? And to solve for B, we need to remember B this side. So we need to remove C by multiplying by the inverse of C, which will give us 1. And then because we multiplied on the left hand side, we must do the same thing here. The same, the left hand side, minus 3, 6, 9, 3, 0, minus 3. And then this one will give us BT, which is equals to C minus 3, 6, 9, 3, 0, minus 3. We need to find C. Let's just try to find C first. C is equals to A minus I3. Then A is 1, 0, 1, 1 minus 2, 0, minus 1, 0, 0, minus our I is 1, 0, 0, 0, 1, 0, 0, 0, 1. That means our answer here would be 1 minus 1, that's 0, 0 minus 0 is 0, 1 minus 0 is 1, 1 minus 0 is 1, minus 2 minus 1, that's minus 3, 0 minus 0 is 0, minus 1, minus 1, minus 0, it's a minus 1, 0 minus 0, 0, 0 minus 1, it's a minus 1, right? That's our C. And now from this, we need to find a C inverse. So how do we find a C inverse? C inverse, let me just find C inverse here. I'm just gonna append 1 minus 3, 0, minus 1, 0, minus 1. I'm gonna append identity matrix 0, 0, 1. Then this will be I'm just gonna add this to 0, 0, 1, 1, 0, 0. That's gonna be 1 minus 3, 0, 0, 1, 0. Then this is 0 minus 3 plus 0, that's minus 3. This is minus 1, 0 plus 0, 0, 0 plus 1 is 1, 1 plus 0, that's 1. I added R2 here. That's R3. And now I'm gonna take this row to be number 1. 1 minus 3, 0, 0, 1, 0. Whatever you do this side, you also do this side. And bring this one down together with this 0, 0, 0 minus Actually, I'm gonna do this. I'm gonna do this. Swap this one to be number 1, then this one to be number 3, this one to be number 2. So 0 minus 3 minus 1 0 1 1 1, and the 12 I'm gonna make it last. So 1 0 0, and then now I've got my first pivot point. Below it I've got zeros. Then I move on, check my second pivot point, which is minus 3, and I need to get a 0 below the minus 3 and above it. Well, below I have a 0, so I need to get a 0 above it. So this is what I'm gonna do. I'm gonna write it here. I'm gonna say minus 3 minus, I'm gonna say row 3, row 2 minus row 1, which will give me 0 0 1 1 0 0. And this will remain in the case minus 1 0 1 row 3. Sorry, did I say row 3? No, I meant to say row 1 minus row 2. Don't want to get a negative here. So I'm gonna say row 1 minus row 2. So 1 minus 0, that's a 1. Minus 3 minus 3, that's a 0. Minus 0 minus 1, that's a 1. And then 0 minus 1, that's minus 1. Sorry, let's say 0 minus 0. 0 minus 0 minus 1 is positive 1. Yes. And then a 0 minus 0, that's a 0. Then 1 minus 1, that's a 0. 0 minus 1, it's minus 1. Then that is, I'm done with this one. So I need a 0 here and here. I'm gonna add this 2, I'm gonna add, then this 3, I'm gonna say row 1 minus row 3, and I'm gonna add row, I'm gonna add row, I'm gonna add row 2 plus row 3. Let's see what happens. But this one remains the same. Zero, 0. Then I add row 2 and row 3. 0 plus 0, 0 minus 3, that's minus 3. 0, 1 plus negative 1, that's a 0. 1 plus 0, that's a 1. 1 plus 0, that's a 1. 1 plus 0, that's a 1. And then this one, I'm gonna say this minus this, which is 1. 0 minus 0, it's a 0. 1 minus 1, it's a 0. 0 minus 0 minus 1, that's minus 1. 0 minus 0, that's a 0. Then minus 1 minus 0, that's a minus 1. Then I divide everything by -3. This one. So it'll be 1, 0, 0, -1, 0, -1, 0, +1, plus 0. This would be -1/3, -1/3, -1/3. And that's 0, 0, 1, 1, 0, 0. Then this will be my inverse. This will be my inverse. -1, 0, -1, -1/3, -1/3, -1/3, 1, 0, 0. So now I can take this inverse and then multiply it with this one. Just delete everything here. So now I can take this inverse, which is -1, 0, -1, -1/3, -1/3, -1/3, then 1, 0, 0. Then multiply it by -3, 6, 9, 3, 0, -3. So this is a 1, 2, 3. This is a 3/3. This is a 1, 2, 3, 3/2. So yeah, this is possible. The answer would be 3/2. So it's possible. Possible. Let's do it. -2, right? So -1 times -3, that's a 3, 3, then plus 0, plus 0, that's a 3. Then we take this one, we go to the second one. -1 times 6, that's a -6, plus 0, plus 3. So -6 plus 3, it's a -3. Right? 6 minus 3. Yeah, it's a -3. We do the same thing here. -1/3 times -1/3, that's a 1. 1 -3. 1 -3, that's a -2. Then we come to this second one. This will be -2, -2, -2 and -1, that's a -3. This is a -3. Okay, this is a -2. Then there's a -1. Then there's a +1. This will be a -2. The last one, -3, 0, 0. It's a -3. Then 6, 0, 0. That's a 6. And then This is our BT. This is our BT. That means this implies that our B is the transpose. We take our columns, we make them our rows 3, -2, -3, -3, -2, 6. Then we come and see if there's anything like that here. Well, there's no answer. So the answer must be this one. Out of the given options. Oh, that's a long one. Yeah, we are done.